I think I should have mentioned this earlier, but try and solve these problems before watching how I solve it. Like, or actually, just maybe watch me solve it and then solve it by yourself. Either way, don't just watch this video. Just, you need to solve it too, whether that be before or after. I don't care, but you need to solve it. Okay, here, oh, okay, sorry. Here we go. A 292 kilogram motorcycle, that's probably going to be our mass, is accelerating up along a ramp that is inclined 30 degrees. That is our degree above the horizontal. The propulsion force pushing the motorcycle up the ramp is 3150. I'm going to call that FP for propulsion, and air resistance produces a force of 250 degrees. No, 250 newtons. Sorry, I'm getting tired. That opposes the motion. Find the magnitude of the motorcycle's acceleration. So let's draw our picture. We are going up a ramp at 30 degrees. I know this isn't 30 degrees. Doesn't really matter, but for picture's sake, I make it a little more exaggerated. So, and I'm not going to draw a motorcycle because I can't. I'm going to draw a box. Oh, I should draw it a little more up here. So we have our motorcycle that has mass m, and it's inclined at 30 degrees. We have a propulsion force. So now we're talking about our forces. I want to write our forces in a different color so kind of easier to distinguish in our picture. So we have our propulsion force that's pushing us up. That'll be FP. But we also have air. What is it called? Air resistance. FA. That's the obvious forces. Now we have to think about the forces that are there but are not told to us. So we obviously have gravitational force, Fg, which is mass times the gravity, right? And then we also have the normal force. I don't know how relevant all of these forces are, but it's important to write them all. So let's kind of organize what we know and what we don't know into a step 2 table. Knowns. We know our mass, 292 kilograms. We know FP, which is 3150 newtons. We know the air resistance, which is 250 newtons. And our unknowns would be our acceleration. So, I mean, we're told that we're accelerating. We want to find our acceleration. Okay, so this is the part that is new, I think. I haven't solved a problem like this before. So previously, all of our problems were our coordinates, what we would set as positive, have been like, 0 and 90. That's what we've always been working with because it made sense. That's what we just want to do. We just want it to make sense. So would it make sense for us to set our positives like this and this in this problem? Because if we did, we'd have to divide this force. We'd have to divide the air resistance. We'd have to divide compartmentalize, I guess, the normal force. That's a lot of work. That's a lot of angles. That's a lot of trig. I don't want to do that. So what am I going to do? I am actually going to set our positives in as this. I'm going to say that this angle is going to be positive. Now, if I do that, the only force vector that I have to divide into its x and y component would be the weight, mg, right? This is the only one that's not in line with this diagonal coordinate system, if you will. So let's just do that now. Let's divide this mg into its x and y. If this line is what we would consider our new 0 degrees, our arrows would look like this and this. I should have wrote these bigger. Let me do that because this part is also confusing and I don't want to skip. I don't want to be confusing. So this is our weight. Oh my god. mg, right? And so I'm going to rewrite these two a little bigger. Uh-oh. Okay. It's going to look like this. Remember, we want to be perpendicular. Perpendicular? Yeah, perpendicular with our coordinates, our 0. And it'll look like this. You can write this arrow from either here or here, right? Start to finish, start to finish. It doesn't matter which way. I just like to keep mine arrows originating from the mass. It doesn't matter. It's just preference. Do what works for you. Dang it. Okay, there we go. Okay, so now we've divided it, but what's going on with these angles, you know? You're like, I don't know how to do this. Well, there's two ways you can do it, actually. You can see that we have a triangle here, right? We have a triangle here. We know this is 90 degrees. So since triangles all end up at 180 degrees, I know that this angle right here is 60 degrees. I know these are at 90 degrees, so I can also say that this is 30 degrees. So with that said, I can now assign this this arrow. I can say that this is mg cosine 30 degrees. Isn't that cool? Okay, anyway, and now to go to this one, you can either use the 60 or 30 degrees. It doesn't matter. You should get the same answer. I am just going to call this mg. I'm going to kind of use this line. So if this would be our 90 degrees, this would be our sine, mg sine 30 degrees. Okay, so now we've have all of our force vectors in a appropriate x and y coordinate. We are good to go to start trying to solve this. I haven't clarified what equation, but I hope at this point it kind of comes to mind. Whenever you see the word force, immediately think F equals ma. Don't even think. Make it instinct, okay? Oh, I wrote step 4. Oops. Yeah, make it instinct. F, well, net force, F equals ma. And I hope that makes sense because ultimately we're looking for acceleration. That's right there. So we want to use that equation. So let's do that. Oh, I think I forgot to mention something. If right or this direction is positive, our air resistance is going to be negative, right? And I guess I didn't finish our step 2. mg cosine 30, I technically haven't calculated that yet. I I haven't done mg sine 30 either. I mean, we'll do that when we get there. I mean, technically, I don't know the normal force, whatever. We're looking for A. Okay, let's just solve this. Okay, so F equals ma. Do not confuse this A with gravity. Gravity works vertically. We are at a new, not a dimension, but we are looking at a new angle. We are looking at the horizontal. Look at, if you could just look at this picture, like shift your paper 30 degrees and make it so this line looks like just 0 degrees. It would make much more sense then. So this A, we are looking just at the horizontal movement of this motorcycle. Okay, don't confuse, don't try to like start thinking like, oh, gravity, or no, we're looking at the horizontal. So with that said, let's look at our horizontal forces. Horizontal meaning this, okay? So we have the force of the propulsion. This is the sum, so it's going to be adding, but we know that if right is positive, left is negative. So I'm going to, well, hold on, I'm skipping a step. I don't want to skip steps here. We have, it's the sum of all the horizontals. So we have force of propulsion, force of air, and mg sine 30. That's our forces. Now let's, what do I not want to do? I'm actually going to isolate A. I'm just going to divide both sides by m right now, so we get a clean equation. I'm going to say that the force of the propulsion plus the force of air resistance plus mg. And I know those who have been solving these know that, I hope like alarm bells are going off in your head right now saying it's minus. Yeah, like I know it's minus. I'm just kind of like doing really step by step right now. Okay, so force of the propulsion, that's 3,150 plus, but the air resistance is going left, right? Technically, not technically, in our slanted world, we're going left. So that means that's going to be negative 250 plus mg, mass is 292. Gravity, if going this way is positive, I mean, okay, a little thing about the signs. It doesn't matter what you set them. You should always get the right answer if you set up your equations correctly, okay? But I'm just going to say that this way is our positive. Gravity would be negative since it's going this direction. I don't really like that explanation, but please follow. All over mass, 292. I mean, just plug it in your calculator at this point, and should I wait for you guys to do that, or should I just say the answer? No, I'm gonna say the answer. I want to go home. Okay, it's 5.03 meters per second squared. That is our acceleration. I know this problem's a lot. It deals with weird angles and new XY coordinates, and it is a lot. That's why you have to solve it many times. I know I'm like a broken record at this point, but if you have any questions, always, contact me and we'll talk about it. Okay. Okay, bye.